Hello everyone. In the previous video, we talked about how to complete this table. So by the end of this table, you should have the buoyant force values versus the fluid density. Of course, you are given here the density of each type of fluid in the table, and the unit of the density is in kilogram per cubic meter. In this video, I'll talk about how to analyze this graph, the relationship between the buoyant force and the fluid density, and also on how to find any extra information from this table by analyzing the data. Now, the first step of analyzing the data is stated here in question number 22 is to plot a graph, Microsoft Excel graph of the fluid density versus the buoyant force, where the fluid density will be on the x-axis because it's the independent variable, and the buoyant force will be on the y-axis because it's the dependent variable. From the graph, we can tell whether the relationship is directly proportional, inversely proportional, just linear or nonlinear, and so on. Now, for the relationship to be directly proportional, it's not enough for the graph to be linear. The y-intercept also has to be 0. We know that linear graph has constant slope and the y-intercept has to be constant as well. But for the relationship to be directly proportional, it has to be linear and the y-intercept has to be 0. Of course, in a real experiment, since there is always room for error, you will not get 100% 0 y-intercept. But if the y-intercept is very close to 0, like within negative 0.4 to positive 1 to positive 0.4, this very much is close to 0. So we can conclude that the relationship between the two variables is direct proportionality. So to plot the graph, the first column will be the fluid density in kilogram per cubic meter. And the vertical axis, which is the y-axis, will be the buoyant force in Newton. And you will input the values that you got in questions 18 to 21 in the lab. And then you'll evaluate the slope and the y-intercept using the statistical function in Microsoft Excel. And again, refer back to my video over lab number 1, which I linked in this lab here. So in the lab assessment, you'll upload the Microsoft Excel graph of the buoyant force versus the fluid density. Then question number 23, it asks you to prove that the buoyant force is directly proportional to the fluid density. And as we mentioned, if they are directly proportional, you should get a straight line with a y-intercept equal to 0. Or very close to 0. In question number 24, it asks you what does the slope of the graph of buoyant force versus fluid density represent? Now, it's very important to watch my video that I linked here. That's the first video. If you watch the video, you'll see that we are going to prove that the buoyant force is equal to the density of the fluid times g, where g is the acceleration due to gravity, times v, where v is the volume of the object submerged, which is also equal to the volume of the liquid displaced as a result of immersing that object. So if you compare this equation to the equation of straight line, and recall the equation of straight line is y equal the slope times x plus v, and if we are taking the fluid density here as our x-axis and the buoyant force as our y-axis, the slope will be equal to what? The slope will be equal to whatever left here, which is g times v. So basically, the slope of this straight line graph will be the acceleration due to gravity times the volume of the object immersed. Okay, so that will give you enough hints to answer question number 24. Then question number 5 asks you to assume we don't know the volume of the bottle that was submerged in the liquid. How can you evaluate the volume of that bottle using the graph of the buoyant force versus fluid density? We can actually do that by using the slope of the graph. Now again, if you go back to this equation, the equation that relates the buoyant force to the fluid density, since the slope is g times v, and since we know that g is 9.8 meter per second square, we can calculate the volume of the object by dividing the slope by g. So again, just to reiterate here, the slope is g times v, the slope of the straight line is g times v, and we need to find v, and we already have the slope from the graph, and we know that g is 9.8 meter per second squared. So we can calculate the volume of the object submerged by dividing the slope of the graph by g, the acceleration due to gravity. Alright, so hopefully this will give you enough conceptual background to be able to solve questions 23 to 25 in this lab. I hope you found this video educational. Please feel free to email me any questions you might have. Thank you.